Hello, welcome to Algeomelis Prep Academy. In today's video, we'll be learning about the shell method. The shell method is used to find volume of a solid of revolution with respect to the variable opposite of the axis of revolution. It's a good alternative to the washer method, or to integrate difficult functions with respect to y or x. This is a model showing what the axis of revolution, height, radius, and the bounds are. It's useful so you know what you're trying to find when using the shell method. For example 1, we'll be finding the volume of the region bounded by the function y equals negative 2x cubed plus 4 in the first quadrant. This region will then be revolved about the y-axis. To find the volume, we'll be using the shell method. Here are the graphs for the function. The first graph is the graph of the function by itself. The second graph is a model of the revolution, and the third is what the object of revolution would potentially look like. Moving on to the next step. Although you don't have the bounds yet, you can still set up the integral, because you know the radius and you know the height of the integral. The next step is to find bounds of your integral, represented here by a and b. A is given because the y-axis and the x-axis intersect and you are in the first quadrant. For b, we need to solve when y is equal to 0. To find b, you need to set the function equal to 0. This will get you where the function intersects at 0, and thus you will get b. Remember when calculating to always use all the digits of your calculation. Now it's time for the final step of example 1. Plug in the bounds you got from the previous steps into the integral formula. The integral formula should already have the height and radius functions in it already. Finally, when you have everything set up, use your calculator to find the answer. For example 2, we are going to be finding the volume of the area bounded by the functions x equals 1, x equals 2, y equals e to the power of negative x, and y equals 1. All of these functions will be rotated about the y-axis. The graph shown on the top left here is a basic sketch of all the functions. The graph on the top right shows a shaded region bounded by these functions. The middle graph shows a single revolution, and finally, the sketch on the bottom is a predicted result of what the solid revolution might look like. Since the region is bounded by the functions x equals 1 and x equals 2, the upper bound is 2 while the lower bound is 1. Since y equals 1 is higher than y equals e to the power of negative x on this interval, the height function is 1 minus e to the power of negative x. The radius function here is simply x. Once you have everything in the formula and the integral is set up, you can go ahead and type the entire thing into your calculator to get the answer. Make sure to pay attention if you are rounding. In the AP test, you're required to round 3 digits past the dot, but other classes may require something else. Moving on to example 3. Here we have a region called R, which is bounded by the graphs of y equals inverse tan x, y equals 2x, and y equals pi over 4. If you rotate R about the x-axis, you get the solid revolution S. We need to find the volume of S using the shell method. Here you can see multiple graphs of R. The graph on the top shows the shaded region of R and all the functions that bound it. The bottom function shows a single revolution of the rectangle in R about the x-axis. Finally, we have a sketch of the solid revolution S. For this next step, we need to set the equations equal to each other to get the other bound. This is necessary so we can integrate. Plug the bounds that we found into the basic shell method formula. 0 is the lower limit, while pi over 4 is a higher limit. Now we will look for the radius function and the height function. To get the radius function, use this format: y minus axis of rotation value. The axis of rotation value is 0 here, so the radius will simply be y. Next, we need to find the height function of the solid of revolution S. You can use the top minus bottom formula. You can refer to graph 1 to determine which one is the top and which one is the bottom. Finally, you need to write the formula again, but this time plug in all the functions you got from the previous steps. This will yield an integral that will give you your volume of S as your answer. Once you have your integral set up, plug your integral into the calculator to get your answer. Once again, please be wary when rounding. Finally, the answer is approximately 0.660. Thank you so much for watching. If this video helped you out, make sure to like and subscribe to discover more helpful videos. See you guys all soon.